We are all consumed by the COVID-19 pandemic, but obesity is a pandemic that has been ravaging the world for much longer. Look around you. 2 out of 5 people that you know are probably obese. That's how common obesity is in the US adult population. This is alarming as these people are at a much higher risk of developing high blood pressure or hypertension. Uncontrolled hypertension is a silent killer as it has no warning signs. Over time, it can lead to stroke, heart attack, heart failure, and even kidney failure. But what if there's a way to break the link between obesity and hypertension and reduce the mortality in obese people? The most common type of fat stored in your body is triglycerides. These are the extra calories that you eat, but your body doesn't need right away. When your body needs energy, this fat is released into your bloodstream and carried around by lipoproteins like very low density lipoprotein or VLDL. Obese people have abnormal levels of VLDL in their blood. It is known that VLDL can stimulate your adrenal gland to produce a hormone called aldosterone. Aldosterone helps your kidneys manage water. Too much aldosterone can cause your kidneys to retain excess water. This increases your blood volume. More volume in your blood vessels increases your blood pressure. We believe that the higher aldosterone levels in obese people is the cause for their hypertension as shown here. Therefore, my research goal is to figure out how VLDL stimulates aldosterone production in order to intervene in the development of hypertension. We believe that VLDL does so through an enzyme called lipin-1. Lipin-1 also plays a role in VLDL assembly and secretion. So we think that lipin-1 could be a potential medicinal target. But would targeting lipin-1 stop aldosterone production? To test this, we used human cells isolated from an adrenal tumor. First, we increased lipin-1 levels by infecting these cells with adenoviruses. With the VLDL stimulus, the cells produce more aldosterone. So now we wanted to see what would happen when we reduced lipin-1 levels. With the VLDL stimulus, the cells produce less aldosterone. These promising results indicate that lipin-1 does play a role in aldosterone production just like we suspected. The next logical step would be to confirm our findings in an animal model. We plan to inject VLDL into normal mice and then check their aldosterone and lipin-1 levels. This is exciting as we get closer to validating lipin-1 as a promising medicinal target to stop aldosterone production and to break the link between obesity and hypertension. Ultimately, we hope to improve the quality of life of obese people by preventing a silent killer like hypertension from creeping into their lives.